Okay, guys, so let's go ahead and finish up John's giant redwood tree on page 4. So we just went over filling out our table and extending it to year 0 and then up to year 7. And then we also used these rules to predict how tall the tree would be 50 years after it was planted. And that was 205 feet because we had to add the 5 feet for the original height. All right, so now we are being asked to plot the points from this table on this graph over here on the next page. Okay, so I am going to remember that this one down here is my x axis, and this one that's going vertically is my y axis. So if I look at the table at year 0, that means at x 0, which is right here in the origin, it was 5 feet tall. So if this side is my feet, and this side is years after planting. Okay, years after planting, then 0 years after planting, the tree was 5 feet tall. So if I look at these scalings, I'm seeing that every block is going up 2, right? So here's 4, here's 6, 8, blah, 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 blah. So at year 0, I'm going to need to be between 4 and 6. All right, my next value I have here for 1 year after it was planted, it was 9 feet tall. So I'm going to go to 1 on my X and then go up to 9, which is going to be in between 8 and 10. All right, next I've got year 2, and it's 13 feet. So I'm going to 2, and then I'm going to go up to 13, which would be between 12 and 14. And then I'm going to continue this with my other values in the table. So at year 4, it's 21. 5 years later, it's at 25. And then 6 years, it looks like I can't fit that on the graph. So we're just going to have to end there. So what does our graph look like? Meaning, if I were to use a ruler, I'm not going to do this right now, but if I held this up right here, this might help show that these points are in a straight line. Okay, this line is completely straight, going up at a very steady amount. Okay, so it is a straight line. And we'll be reviewing what proportional relationships are a little bit later in this unit. Well, technically this should have been last year, but we'll review that in a little bit. But although this is a straight line, which would be a proportional relationship, the proportional relationship also has to start at the origin. So again, if I look at these lines, or these points, excuse me, my line does not go through the origin right here. And that tells me that this is not a proportional relationship. Okay, no, does not start at origin. All right, now this next one, it says doesn't make sense to connect the points. All right, so when we're thinking about whether or not it makes sense to connect points, we have to think about what's happening in between these values down here. Okay, so in between 1 year after being planted and 2 years after being planted, what's happening to the tree? Is it staying at 9 feet tall until through the 365th day when it just sprouts up another 4 feet? No, right? The tree is going to be consistently growing throughout that year. So, since there are things happening in between here, things are still changing, and it is possible for it to be in between these, right? Like it's possible to be at 1.5 years or 4 years and a quarter, right? It's possible to have parts of years. So, because of that, it does make sense for us to connect these points in a line. Okay, so you can use any of the things that I just said to help explain your thinking down here. Okay, so go ahead and put that into your own words. And now, like we said, according to the graph, what is the height of the tree 1.5 years after it was planted? So, since we drew that line, I can look at my graph and go to 1.5 years, which means 1.5. So, right in between 1 and 2. And I can use this to tell that at that time, oh, it looks like it was about 11 feet at 1.5 years after being planted. Okay. But now, can I use my table to predict the height of the redwood tree 20 years after it was planted? Why or why not? So if I'm looking at my table here, or I'm sorry, at my graph, I want to know the height 20 years after it was planted. I can't really do that with this graph. Okay, and there's a very simple reason. We can't use this graph to predict how tall the tree would be 20 years after being planted because 20 years does not fit on our graph, right? If I have years down here on my horizontal, I can only use this graph up to 6. If I extended this out, I'd have to go really far, but if I extended it out eventually, I could see it. But with this snapshot that I have of the graph right now, I don't have enough room, enough information to be able to create a clear prediction just using the graph. Yes, we can use the rule to make predictions in other ways, but if we consider just this graph, we don't have the ability to predict 20 years after it was planted. Okay, so again, you can use any of the reasoning that we just talked about, but no, we do not have the ability to use this graph to predict how tall the tree would be 20 years after it was planted. All right, and then this table down here, it's just asking, like it was just giving you another place to copy down this table so that it was easier to graph, and I kind of forgot about that, so I'm just going to go ahead and copy down my values from that table that I have up here. All right, and then that is all we're going to be doing with John's Giant Redwood for right now. Later down the line, a little bit, we're going to practice using this rule to write an actual equation that represents this relationship. Okay, so stay tuned for that and have a good day.